Okay, so here we are going to look at a quadratic applications problem. And when you're working with quadratic applications, there's a lot of different things they can ask you in regards to a quadratic. So in this example, we're going to look at a lot of different types of questions they can ask. Here we've got a football. It's being kicked. The height of the football, f of x, is in feet and is modeled by this function that's given here. X is the ball's horizontal distance, also in feet, from the kicker, and they're given us permission to round to 2 decimal places. So let's just kind of visualize what's happening here. So we've got a football kicker, and I'm going to put that kicker right here on the y-axis, okay? And they're going to make contact with this ball right in here, okay? And then we all know that the footballs follow this kind of parabolic path here, okay? So imagine that parabola that football's going to travel. So this is when it was kicked, and then the ball's traveling. So they have defined the height in feet. What that means that this is f of x. This y-axis is our f of x. That's in feet. That's the height. And they've also defined that x is your ball's horizontal distance, also in feet. So this is, they're both in feet here. So feet along this axis and feet along this axis. And you just need to always carefully read how the variables are established, because sometimes your x could be a time in seconds or number of people. You really need to read how the function has been defined, okay? And then think about how that looks. So it says, what is the football's maximum height and how far from the point of impact does this occur? So if we sketch this out again, okay, we've got this parabola. All right, and our maximum height is going to be right here. This is our vertex. Okay, so we know how to find a vertex. We can use negative b over 2a to find the x value of the vertex. And so we're going to grab those values from up here in the function. All right, it'll be negative 1.18 over 2a. So that'll be 2 times negative 0.01. Divide this out, and you're going to get a 59. Okay, so this is the x value of the vertex. Okay, so if you think about a point having an x value and a y value, so this is x and this is the f of x. All right, we just found the x part of that point. Okay, so we found this distance right here is 59. Okay, now we need to find, it says, what is the maximum height? We haven't actually found that yet. We just found that 59 is at the point that this occurs. Okay, so we're 59 feet this direction when that maximum occurs. So now we need to take our function and evaluate it for this value of 59, which means that you're just going to put a 59 into the function everywhere there's an x. And then you're going to pop this into the calculator and see what you get here. So that comes out to 36.81. This is also going to be in feet, right? And so that's the y part of that point, okay? So that's this point over here. This is 36.81. So that's our height, okay? That's our maximum height that occurs when it's 59 feet horizontally. It is 36.81 feet vertically, okay? So our maximum height is 36.81 feet. This occurs when the football has a horizontal distance of 59 feet. Sorry for the bad handwriting. This little pen stylus that I have to use is Very grumpy. Anyway, so be careful since both of the, these are feet in both cases. You want to make sure you're clearly explaining which one is the maximum height and which one is that horizontal distance, okay? So another question they can ask is something like this. It says, if the nearest defensive player is 6 feet from the kicker's point of impact, how high must the defensive player reach to block the punt? So if we could draw out this situation here, okay, and once again, we've still got the same parabola happening, okay. So what they're saying now is if we go 6 feet this direction here, okay, there's a defensive player right in here. There's my little stick figure there. And like I said, we're 6 feet away from where that ball was punted or where it was kicked. So they're wanting to know, okay, how high is this right here? If you're 6 feet away this way, what is the height at that point, okay? So essentially all we need to do is take our function and evaluate it for an x value of 6. So everywhere there's an x, you're going to put in a 6 and pop that into the calculator and see what you get. And you get 8.72, and that will be feet. So that means the defensive player would need to get up to a height of 8.72 feet in order to block that punt, right? So a defensive player must get to a height of 8.72 feet to block the punt. So probably someone's not going to be that tall, but maybe they can jump up and get their hands up and maybe block the punt. Okay, so now it's saying, okay, if the ball is not blocked by the defensive player, then how far down the field will it go before hitting the ground? So here's another situation, another type of question they can ask. Okay, so once again, we'll just redraw this out. So now they're wanting to know, hey, when does this happen? If it's not blocked by the defensive player and the football travels all the way, as far as it travels down the field, when does this happen? What is this x value here? This is an x-intercept. Okay, so we're essentially looking for an x-intercept. And we find our x-intercepts by setting our function equal to 0, okay? So we are going to take that function that we've been given, and we're going to set it equal to 0. And I am just using this same function that was given up here and setting it equal to 0. Now, why are we setting it equal to 0? You wonder, is that's your height, right? If you're on the ground, right? Because they said, when does it hit the ground? That's a height of 0. Right? So we're saying, hey, when is f of x, which represents our height, equal to 0? So that means we can take this function here, set it equal to 0, and solve. And we're going to have to use our quadratic formula here to solve this, okay? So we know quadratic formula, right, is negative b plus or minus square root b squared minus 4ac all over 2a. And we're going to pull our a, b, and c from the function. So we're just going to set this up with our values in there for a, b, and c. Being very careful that we get all our negative signs in there and so forth. Okay, and what I tell students all the time is just get the number under the root. Don't, it's not a great idea to just try to punch the whole thing in. It's usually a better strategy to just get this number under the root first, see what you're dealing with there. In this particular situation, we've got 4724. Once I just punch in this, what's inside that b squared minus 4ac. Okay, and on the bottom, Okay, so then you want to then type in the top and then divide out with the bottom. Okay, so you'll do it with the plus sign and you'll do it with the minus sign, and you're going to get two answers. So you get 1.6712 blah 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 blah, and then you get 119.6712 blah blah blah. And I encourage you to punch that in and make sure you're getting these numbers. Make sure you're not making some calculator error. Up at the top here, it did give us permission to round answers to 2 decimal places. That is only at the end of the problem. Notice I have not rounded any of these other decimals throughout the problem. We want to keep all of that stuff going. You're only allowed to round at the very end. Okay, so be careful with that. So we'll say negative 1.67, and then here we'll say 119.67. Okay, and this is feet, and this is also feet. Okay, so remember these are x values. That's what, remember, this is x equals. So we found x values. So what we found is if we were to extend this parabola kind of the other way over here, this is that negative 1.67. So that obviously doesn't make any sense in context of this situation. Okay, so we're going to throw this one out because, you know, the football, we already talked about how the football was kicked here. So the situation started right here. Okay, so we're not going to backtrack to that. And then this here is the other distance. So this is going to be the 119.67 over here. Okay, so that means your horizontal distance here is going to be 119.67 feet when it hits the ground. Okay, so circle that. That's our final answer there. All right, now here's a last combination that I came up with is when they're asking you to determine, hey, what time is the football at a height of 20 feet? So they're not asking for the maximum height. Up here, this was the maximum height. We found the vertex. They're not asking when does it hit the ground like they were asking here. They're not giving you an x value. This is not an x value, so we can't do it like we did here where we just plug the 20 in. Okay, they're giving us a different height, right? They're saying, hey, when is your height 20? Okay, and so when is f of x equal to 20? So we're going to just take that function that we were given, and we're going to set it equal to 20. Okay, and once again, we're using this because they are specifically asking for the 20. Now, before you do quadratic formula, you always have to have the function set equal to 0. So in this case, we need to subtract that 20 over to the left side. Okay, and then I can quadratic formula this guy here. So I'm just going to quickly write that out. Okay, so you want to put all your numbers in for your A, B, and your C. Once again, go ahead and just figure out what this inside part is here. Okay, so I believe, let's see here, that is 0.6724 when you do the inside, the b squared minus 4ac. Okay, and then work on the top and then dividing by the bottom with the plus sign and then with the minus sign and get your two answers. So you get an 18 and you get a 100. Okay, so what we found here are 2 points. Okay, this is important that you understand what this means. Now, the y value for each of these 2 points is 20. Okay, and we found an x value of 18 and we found an x value of 100. So we found 2 points. So if we sketch this out again, okay, and we think about that football flying through the air, okay, and let's say this is a height of 20 right here, okay, then actually the football hits that height twice. It hits it this time, and then it keeps going up, hits that maximum up there, comes back down, and then hits it again over this way. And essentially what we found here is this x value is 18, the first time it hits that height of 20. And then the x value here is 100, and that's the second time it hits that height of 20. So this is like that point here, 120, right? And this is that point, 18, 20. Okay, so you found 2 points along your parabolic path where the y value, or the height, is specifically 20. Okay, and so this happens at 18 feet and at 100 feet. Okay, these are your 2 times when the football is at a height of 20. So like I said, just tried to show you some different combinations here. This was maximum, and we had to find the vertex to answer that question. This was, they're giving you a x value, you're just plugging it in. This one, they're wanting to know this x-intercept right here, so you're setting it equal to 0 and solving. And then this one, they gave you a different height, and so you're plugging that in and then solving accordingly. So anyway, keep practicing, and I hope this video was helpful.